Okay, so section 8.8 improper integrals. Okay. So the improper integrals, the definition of improper integrals, the definition of a definite integral, for example, if I have a and b, fx and dx, example 1 to 2 x squared dx, for example, this kind of integrals, it requires the interval, okay, requires a and b be finite. So you have finite boundaries. For example, 1 and 2, they are finite numbers. You cannot say infinite. Okay, if it's infinite, it's improper integral. So this is a definite integral. Okay, and f is continuous. On a and b, so this is what we call definite integral. So basically, you can find exactly. You take the antiderivative, plug the up boundary, lower boundary, subtract those two, and you got your final answer. So this is how we do the definite integral. Okay. So next one is if either one of the both of the limits of integration are infinite, or f has a finite number of infinite discontinuous points. This is called improper integral. Okay. So what is an improper integral? Improper integral if either one or both boundaries, either one or both of the limits of integration are infinite. Like infinity, you know that, right? Infinite. Or f is discontinuous. F has a finite number of infinite discontinuous points in AB, and this is called a improper integral. Okay, so if one or both of the boundaries are infinite, and infinity, or the f has finite number of discontinuous points during that interval, so this is called improper integral because it gets involved with infinity things. Okay, so for example, you have negative infinity to positive 2, 1 over x squared dx. You can see this is an infinity. It's a negative infinity. Okay, this is the improper integral. That makes sense, right? You have a negative infinity here. Or, for example, you have 3 to positive infinity e to negative x dx. You have a infinity on the top. This is also an improper integral. Or negative infinity to positive infinity, 1 over x squared dx. Okay, so you have a infinity, negative infinity, so this is also a improper integral. Or you have 1, 2, 3, 1 over x minus 2 dx. Well, when x equals 2 is undefined. Okay, so x equals 2, x cannot equal 2. But x equals 2 is between the boundary. It's in between 1, 2, 3. In this function, x cannot equal 2. So this is an improper integral. That makes sense, right? Because 2 is between 1, 2, 3, but 2 cannot be defined for this function. So we have to separate this integral. If we have to find the integral, find the value of this one. Do from 1 to 2, then from 2 to 3, like that, okay? So this is an improper integral, or example of improper integral. So how do we find the antiderivative of improper integral? So first one, if f is continuous on a to infinity, then from a to positive infinity, fx dx equals limit b goes to infinity, a to b, and fx dx. What's the meaning of that? You look at this equation. Well, the left side, it is an improper integral, but right hand side, I changed the infinity into a variable b. B is kind of like a we changed the infinity into a first a finite function, so finite boundaries, but b goes to infinity. Okay, b itself, it just approaches infinity. Okay, then you can find a limit. Okay, you change that as a limit. Say what's the limit when b goes to infinity? What is the answer? Okay, so how do we do that? How to use this equation to find the integrals? For example, from 0 to infinity, e to negative 4x dx. So this is an improper integral because I have infinity in the up boundary. What do I do? You can change the boundary into a limit, b goes to infinity. Change the up boundary into a finite number b, but b just into a variable b. You can say that b approaches infinity. Okay, b itself is a kind of like an up boundary. Okay, you can consider that is infinity is not a fixed number. You cannot change. You cannot say, oh, infinity is something. No, it always never end. Okay, now I change it into a b as a variable. B is something finite, but it approaches to infinity. Okay, so what I do, I change the b goes to infinity, change the whole thing to a limitation from 0 to b, and e to negative 4x dx. So in this way, you have a b, you can plug a b in. Okay, so what do? You can do negative limit b goes to infinity, and then the antiderivative of e to negative 4x. So I have a question here. Can anyone tell me what's the antiderivative of e to negative 4x?
E to the negative 4x over negative 4.
Very good. Thank you very much. E to negative 4x over negative 4. Okay, so now, then I can plug the boundary into that. So it's plug b into here, plug 0 into it. So what do you have? You can plug the up boundary, lower boundary, limit, b goes to infinity. Okay, so e to negative 4b. You can see you can change that into b, change the x into b, and then negative 4 minus, the other one doesn't have b, you just minus it, e to negative 4 times 0, which is e to the 0 is 1, you know that, is negative 4. So my next question is, when b goes to infinity, what is e to negative 4b? Can anyone tell me? So b goes to infinity, what's the e to negative 4b? What's this value?
0.
0. Why is it 0?
Because then you're putting e to the infinity, and it's 1 over e to the infinity.
That's perfect, yes. If you put it down, thank you very much. That's a very, very good answer. Yeah. If you put it down, you got e to 1 over e to positive 4b. Because e to negative 4b, you can bring it down to the bottom is e to positive 4b. Okay. And then you times negative 4. This is the infinity thing. It's 1 over infinity times negative 4. It's still 1 over negative infinity. It's 1 over positive infinity, 1 over negative infinity. It also approaches 0. So it's 0. Okay, so the whole thing is the infinity in the bottom. And the minus is plus. E to power 0. 之间, what is e to power 0? You press the button. Okay, e to power 0 is 1. So minus is a plus, so it's plus 1/4. So the whole thing equals 1 over 4. And we're down here. Okay. Does the whole thing make sense, everyone? It does, right? Okay. All right, so next one. If f is continuous, this is what? This is the upper boundary is infinity. Now we change our lower boundary to be a negative infinity. So what happened? So if f is continuous on negative infinity to b, and then from negative infinity to b, and fx dx, you can change that into a limit. A goes to negative infinity, and from a to b, and fx dx. Okay. So you can change the boundary into a to b. A goes to negative infinity, and then you a and b you can plug into the antiderivative in the end. Okay. Number 3. If f is continuous on negative infinity to positive infinity. So now both the upper and lower boundary are infinity. Okay. Then you have negative infinity to positive infinity. You have both up and lower boundary are infinity. So fx dx equals negative infinity to c fx dx. Then this is only one thing. It's only one boundary, right? And then plus c to infinity fx dx. Okay. So for each of them, you can use a and b. For this one, you can use limit a goes to negative infinity and a c fx dx. For this one, you can use limit b goes to positive infinity and c and b fx dx. So now, when you look at this one, it doesn't have infinity anymore. Infinity goes to limits. This one, it doesn't have infinity anymore because the infinity goes to limits. Okay, so let's look at another example. From negative infinity to positive infinity, 4 over 16 plus x squared dx. Negative infinity to positive infinity, 4 over 16 plus x squared dx. Okay, so since we have infinity and positive infinity here, we can break down the negative infinity to positive infinity into negative infinity to which number? Can you tell me a middle number between negative infinity to positive infinity? Can anyone tell me a middle point?
0.
0, very good. Thank you very much. So normally, we break into a middle point. 0 is good number because 0 can make e to 0 is 1, sine 0 is 0, tangent 0 is 0. 0 is a very good number for a lot of functions. So just break it down to 0. And 4 to 6, 4 square plus x squared dx. And plus 0 to infinity 4 plus x squared dx. Okay, so I'll give you 3 minutes work. You practice by yourself and finish both of them like the previous example. Okay. You know what is antiderivative of x squared plus a squared, right? 1 over x squared plus a squared is 1 over a arctangent x over a. My formula is okay. This is a plus c. Please finish the this two by yourself. Try. Okay, so let's continue. Have you done? Okay. So I would like the student help me with this one. Can any volunteer? Any student would like to help me continue here? Taylor, could you please help me with this one?
Well, we can rewrite that to 1 over 4 inverse tangent of x over 4.
Where is the limit?
It'll be from negative infinity to 0.
Okay, but you need a limit for the for lower boundary, right? To do this?
Yep.
Yeah, you have the 1 over 4. Wait, it's not a 1 over. So 4, you have the 4 on the top numerator. You can take it out. So let's just do one more step in between. I don't want to do it like so quick, then you made a mistake. A to negative infinity we change the a to 0, 4 over 4 squared plus x squared dx. Then plus limit b goes to infinity, 0 to b, 4 plus x squared, 4 squared dx. So then this one and this one it's kind of like a finite. You can treat them as a finite integral, definite integral now. I change the infinity into the limit. So it's limit a goes to negative infinity, 4 times 1/4, because the up is 4. So now I change that into 1 and 1/4, and the antiderivative has 1 over 4. The numerator has another 4, so these two cancel out. Then times tangent inverse of x over 4. And you have 0, a to b, right? So it's a to 0 plus.
Wouldn't it just be the same thing, but instead of a to 0, it would just be 0 to b?
Yes, it's going to be the same thing. It's going to be tangent inverse of x to 4 and 0 to b. But here you have to put another limit here, because b goes to infinity, a goes to negative infinity. You have to put another infinity here, b to positive infinity. It's the same thing. It's going to repeat again, 4 times 1/4 and times tangent inverse. Well, when you do that, you don't have to write all of the 1/4 again. If you know the answer is 1. Okay. This is the same as the previous one, just 0 to b. Okay. So now we just need to check, plug it in, tangent inverse of 0. Well, there's another way you can write it. Okay, there's another way you can do this. Limit a goes to negative infinity, b goes to positive infinity, 4 times 1 over 4, and tangent inverse of x over 4 from a to b. Both are. Does it make sense? You can write as 1, use a goes to negative infinity, b goes to positive infinity, put them in one function. That is okay. That's fine. Okay. So because here a is kind of finite number, b is a finite number, so just plug it in. Okay. So now what do? You have negative infinity, a goes to 0. You take the 0 in, tangent inverse of 0, which is 0, minus. Okay, so a goes to negative infinity. Can anyone tell me what is the tangent inverse of negative infinity? Tangent inverse of negative infinity.
Negative pi over 2.
Negative pi over 2, perfect. Okay, very good. So if you draw the picture, you can tell the pi over 2 is right here, pi over 2, and the tangent function is like this. Okay, so negative pi over 2, it approaches to negative infinity. Positive pi over 2, it approaches positive pi over. This is one period tangent function. And plus tangent inverse of, plug b into that, tangent inverse of infinity is pi over 2. Tangent inverse of 0, which is 0. So simplify that, negative, positive pi over 2 plus pi over 2, the whole thing is pi. Okay. So I want to know how many of you got a pi in the end. Could you please raise up your hand? How many of you got a pi? None of you? Okay, so which part has at which point it stopped? Just okay.
Knowing the tangent, or our tangent of negative infinity is pi over 2.
Okay, yeah, this part, okay. If you know that, and if you got this, if in the test to give you this and you're not this, I put a mark of 2 or 3 points here. Okay, so majority of them are right. In 1 and 2, let me see the other one. Let's see another example. Before the example, I want to look at a property. Sometimes if you go to infinity, it probably does not converge to one point. We're going to say example. In 1 and 2, did I have a 1, 2 in the previous? Yes, we do have 1 and 2 in the previous. In 1 and 2, the improper integral converge if the limit exists. You know what I mean, right? In the first one, if you plug, for example, this example, you plug the limit of b goes to infinity, the e to the positive 4b, you plug it in, is 0. This is 0. Is 0. This means the limit exists. It does not go to infinity. Okay, it means it exists. If the limit exists, then the improper integral converges, which means you can find a finite answer for it. Okay, well, in 3, since I have 2, you see here, I have 2 improper integrals. Both of them have to converge, then it converge. If one of them diverge, then the whole thing will diverge. The integral diverge if either one of the right two diverge. I have 2 integral here, 2 improper integral here. 2. This is the first. This is one. Another one. If one of them diverge, goes to infinity, the whole thing will diverge. Okay. So let's look at an example. Say when we have a diverge integral. A lot of improper integrals are diverge. For example, just a very simple example: 0 to infinity x dx. This one, you can definitely see it's diverge. Okay, because you can see you change the limit into a b goes to infinity. The antiderivative of x is x squared over 2. Plug 0 and b into the infinity. Okay, so now is limit b goes to infinity, half of b squared minus plug 0 into here, so it's half of 0 squared, so 0 over 2. The whole thing, this is 0. Is infinity squared is infinity. Infinity squared is infinity over 2 is still infinity. So this whole thing is infinity. And that means it's diverge. That makes sense, right? Because the limit, it does not exist. The limit itself diverge. So the whole thing will diverge. Another simple example. From 1 to infinity, 1 over x dx. You can see this one is limit b goes to infinity, and from 1 to b, 1 over x dx. The antiderivative is ln. Limit b goes to infinity, ln x, plug 1 and b into it. So it's a limit b goes to infinity, ln b minus ln 1. Well, this one goes to infinity because this is 0, this is infinity, and this one diverge. Just diverge. That makes sense, right? Okay. Then let's look at one more example. Not diverge, but just another one, because we have infinity. Whenever you have infinity, you have limits. Sometimes you have to use L'Hopital's rule. Okay. Some people say L'Hopital's rule, but it's 2 people's name together. Okay, so you can use L'Hopital's rule. From 0 to infinity, x squared e to negative x dx. Okay, so now I will give you 2 minutes to, 3 minutes to try this one by yourself. Bella, do you have a question?
Huh?
Do you have a question?
I don't know how to go about this.
Or you don't know how to go about this? So let me give you a little bit of help. Limit b goes to infinity and 0 to b x squared e to negative x dx. Now if you treat this as a finite integral, don't consider about the limit first. Can you find the antiderivative of this one? That makes you feel better. This is x squared, this is e to negative x. Use tabular method. Okay. Is anyone done? Okay, are you stop at some point? Can you tell me what you got right now? Can anyone tell me what you got right now? It doesn't have to be the final right answer. I want to know what your answer right now, what you got right now. So even you cannot plug the b in, at least you have something. Like if I give you 1 to 2 x squared e to negative x dx, everyone should know how to do this one for sure, right? So now you should change the 2 into a b. At least you have to have something with the b. You just plug the 2 in, plug the b in, it's the same thing. It's just not the last part. Probably when it goes to infinity, you probably need a little bit of help. But before that, you should be able to do that, right? So can anyone tell me what your answer right now is? If nobody help me, I'm going to call a number. Call a name. Anyone? Okay, so Luke, can you help me to finish this integral?
So with the tabular method, u would be x squared, and dv would be e to the negative x.
Right.
Then the derivative of u is going to be 2x, and the integral of dv is going to be negative e to the negative x. Then the next derivative is going to be 2, and then back to positive e to the negative x, and then 0, and negative e to the negative x. And then you have the plus minus plus on the left. And so you have x squared e to the negative, or negative e to the negative x.
Okay, just keep that. You don't have to worry about the limit right now. Okay.
Right.
Yeah, so x squared.
Minus 2x e to the negative x. Minus 2 e to the negative x.
Very good, perfect. So what's next? So what do you have any idea what do we do next? So we have an e to negative x, e to negative x, e to negative x. What do you think we can do? Look.
You didn't factor that out?
Yes, we can factor out e to negative x. Then it's negative x squared, negative 2x, and negative 2. Plug 0 and a b. B goes to infinity. So this is infinity. Okay, so now, as I said, this is the L'Hopital's rule. You have to use the L'Hopital's rule. Even you don't know how to use the L'Hopital's rule, because the thing is, why is negative? You have to use the L'Hopital's rule. Because b goes to infinity, then this is the e to negative infinity thing. So this is going to be a what? Can you tell me? Look, probably you know that. B goes to infinity, plug in this one here. What is this? What is e to negative infinity? Can you tell me what is e to negative infinity?
0.
0, very good, yeah. So now, what I need to do, I have something, b goes to infinity, plug b into here, so it's e to negative b. Negative b squared, negative 2b, negative 2. Okay, minus, plug 0 into here, 0 into here is 1, 0 into here 0, 0, 0 minus 2, which is 1 times negative 2, so it's still negative 2. Okay, plug 0 into the 1 times negative 2, everything is 0, and plug except this negative 2, so it's negative 2, negative 2 is positive in the end. So now my problem is not this part, it's this part. E to negative infinity is 0, and this is negative infinity. Plug b into here is infinity square, so this is negative infinity. Now I have 0 to negative infinity form. Can I apply the L'Hopital's rule right now? Yes or no, everyone? I have 0 into no. Okay, very good. So what kind of form do I need? I need a 0 over 0, infinity over infinity, negative infinity, positive, negative is okay, either one. Okay, this, if I have this kind of forms, then I can use L'Hopital's rule. This is 0, this is infinity. So can you tell me how to change the 0 into infinity?
You can rewrite that as 1 over e to the b.
That's perfect. Okay, that's perfect answer. Very good answer. So if I change, whenever you see a 0 times infinity form, you always want to change the 0 in the bottom as another 1 over 0, 1 over the 0. So you always put that 0 into the bottom. So here, which is good, and I can put the negative e to negative b in the bottom as e to positive b. Okay, or 1 over e to negative b. So it's 1 over again. So it's e to negative, put it down, e to power b. Negative b squared, negative 2b minus 2 plus 2. Okay. So I think next, I think you can do that. This is infinity form. Top is infinity, bottom is infinity. Okay. If I take the use the L'Hopital's rule, it's going to be like a negative x squared, negative 2x minus b, and e to power x, limit to x goes to infinity. That makes sense to you, right? So if you use the L'Hopital's rule, the top will give you negative 2x minus 2 e to x again. It's still a negative infinity over infinity form, so use the L'Hopital's rule again. So x goes to infinity, and this is negative 2. This is e to x. So now you can plug it in. The whole answer is 0. That makes sense, right, everyone? Because exponential function increases faster than the polynomial function. This e to infinity it goes way more faster than the polynomial function. So if you use the L'Hopital's rule, you take derivative twice, the numerator become a number, but the denominator is still an infinity thing. So the whole thing for this one is going to be a 0. Use L'Hopital's rule twice. Okay, then you plus 2, so the answer is positive 2. Okay, does that make sense, everyone? Yes, it makes sense, right? Okay. So let me say, probably I can give you an example you practice by yourself. Example for practice. 0 to infinity. What did I do? Just give you one tool for yourself to practice. E to negative x dx. Okay. I want to practice this one fault. Just repeat the previous process again and see if you understand the whole process. I want to try this one. Okay, are you done? Okay. I think it's almost ready. Okay, so now we have like, can anyone tell me what your answer is in the end? What's your final answer? 1. Very good. I think that's right. Okay. So I would like a student. Well, we don't have too much time on it. Okay. Let me just finish real quick. Limit b goes to infinity. 0 to b. X e to negative x dx. So I use the L'Hopital's rule. U is x 1 0. dv is e to negative x. Negative e to negative x, e to negative x, positive, negative, go like that. Okay, so I still have e to negative x and negative x minus 1. Plug 0 and a b in. You got the same thing, everyone? So then you got a limit b goes to infinity and e to b. And then the top is negative b minus 1 and plot minus e to 0 is negative 1 is negative 1 0 negative 1 again, and then you use L'Hopital's rule. This will give you a 0. Use L'Hopital's rule. This is 1 and this is the e, still e to b. Okay, use L'Hopital's rule here, and it is infinity. Derivative of b is 1, so it's negative 1 over e to b, which is still into infinity, and plus 1. And b goes to infinity is 1 over infinity is 0 plus 1, so the final answer is 1. Okay, so how many of we got 1 in the end? Could you please let me know? Very good. Okay, almost everyone got at 1. That's perfect. That's very good for today's class. Okay, I'll see you tomorrow. We're going to do more examples and finish this section. I'll assign this week, the homework for this week, and also the chapter quiz for chapter 8. Okay, so I think when is our second test? Is it next week? Next Friday, right? Okay, that's good. I think everyone should be fine as long as you finish your homework, finish your quiz, everything on time. You'll be okay. Okay. If you have any questions, just feel free to email me, and